Okay, so for our next problem, we will be dealing with a square, and each corner of the square, meron tayong mga subatomic particles, which is itong mga to. And these subatomic particles, they differ in charges. Now the question is, what is the net force on Q1? So ito yung Q1 natin. Ano daw yung force na nararanasan ng Q1 with respect to these subatomic particles, which are Q2, Q3, and Q4. So again, ano daw yung net force sa Q1? Yun yung hinahanap sa problem na to. Now first, identify muna natin yung mga type ng forces. So between Q1 and Q2, since pareha sila ng charge, magre-repel lang sila. Between Q1 and Q3 naman, mag-a-attract sila since opposite charges sila, the same with Q1 and Q4. So, solve natin yung force between Q1 and Q2, Q1 and Q3, Q1 and Q4. Ngayon, unahin natin yung Q1, Q2. So, gagamitin lang natin yung Coulomb's law. Yung Coulomb's formula, which is Coulomb force is equal to the K constant times Q1 times Q2 over distance squared or R squared. Ayan, substitute lang natin yung mga given between Q1, Q2 dito sa formula natin. So, lagyan lang natin to ng 1, 2, since para ma-denote na Q1 and Q2 to. So, substitute lang natin dito. So, that would be Fe is equal to the Coulomb constant, which is 9 times 10 raised to 9. Then the value of Q1, that would be 2 times 10 raised to negative 7. And the value of Q2, which is 1 times 10 raised to negative 7. Over their distance squared. So, ano ba yung distansya ng Q1 and Q2? That would be 0.05 meters. So, isi-squared natin yan sa ibaba. So, 0.05 squared. So, input nyo lang to in your calculators. That would be 0.072 newtons. Yan. That would be the Coulomb force between Q1 and Q2. And ang force na to ay repel na type of force dahil parehas na sila ng charges. So next, we will find the force between Q1 and Q3. So gagamit lang ulit tayo ng Coulomb's law o yung Coulomb's formula. So again, Fe is equal to 1 to 3 since Q1 and 3 yung hinanap natin. So that would be the Coulomb constant, which is 9 times 10 raised to 9. And what is the value of Q1? 2 times 10 raised to negative 7. What is the value of our Q3? That would be 1 times 10 raised to negative 7. 1 times 10 raised to negative 7 over their distance squared. Ngayon, hindi natin pwede gamitin yung 0.05 meters. Dahil as you can see, ito yung distansya nila. Oh. That would be their distance. Hindi ito, hindi ito. Hindi addition ito or hindi addition ito. No. This would be their distance. Ito, itong diagonal na to in a box or in a square. So, paano natin mahahanap to? Ito, itong part na to. We can use the Pythagorean theorem using these two sides. So, as you can see, makakabuo ka dyan ng right triangle. So, that would be distance is equal to the square root of 0.05 squared plus 0.05 squared. So, makukuha mo na yung distansya between Q1 and Q3 and that would be 0.071 meters. 0.071 meters. Ngayon na may distansya na tayo between Q1 and Q3, may masasubstitute na tayo dito sa ating Coulomb law o yung formula natin. So that would be 0.071. So input nyo lang to sa inyong mga calculators. The answer would be the Coulomb force between Q1 and Q3 is 0.036 newtons. Now, may value na tayo ng force between Q1, Q2, and Q1, Q3. Hanapin na natin yung sa Q1, Q4. So, 1, 4. So, madali lang to. Hindi na natin need mag-change ng ating distance dahil ito na yung kanilang distance. So, 0.05 meters pa rin. So, that would be 9 times 10 raised to 9. The value of Q1, which is 2 times 10 raised to negative 7. Value ng ating Q4, parehas lang. 2 times 10 raised to negative 7. Over their distance squared, which is 0.05 squared. Input nyo lang to sa inyong calculator, and the answer would be Fe14 is equal to 0.144 newtons. So that would be the answer. Okay, so now that we have the assigned values for F's, pwede na natin mahanap yung net force in Q1. So the formula for net force is the summation of x squared plus the summation of y squared. So tong x and y na to, these are the x and y component of the forces. Kaya before finding the net force on Q1, hanapin muna natin yung x and y component of force between Q1, Q2, Q1, Q3, and Q1, Q4. Now, in finding the x and y component of force, isipin lang natin na meron tayong Cartesian plane. And in this Cartesian plane, yung magiging origin niya is yung subatomic particle na hinahanapan natin ng net force. So, ano ba yung subatomic particle na hinahanapan natin ng net force? That would be the Q1. So, magdodrawing lang tayo ng Cartesian plane, mini Cartesian plane. Ayan. So, as you can see, yung magiging origin ng Cartesian plane natin is itong Q1. Now that we have the Cartesian plane, hanapin na natin yung x and y component of force. So, unahin natin yung Q1 to Q2. So, since yung Q1 to Q2 is a straight line, isa sa kanyang x and y values ay 0. And since it is a vertical line, yung x yung magiging 0. Now, as you can see, the force between Q1 and Q2 is repel. Repel yung force nila. Ibig sabihin, maghihiwalay sila. Now, si Q2, nag-e-exert kay Q1 ng force pababa since naghihiwalay nga sila. And ang pababa sa Cartesian plane ay negative. So, ang value ng ating y ay negative 0.072 newtons. Now, let's move on with the force in Q1 to Q3. So, hanapin natin yung x and y component of force niya. So, yung force between Q1 to Q3, angled force siya. Hindi na lang siya basta straight na force. Angled force siya, so meaning parehas may value yung kanyang x and y. Now, ito siya inside the square. Ito yun, 'di ba? Yung Q1 to Q3. That's our force in Q1 to Q3. Ayan yung 0.036 newtons. So, in a square, there is a rule na pag may diagonal, both sides of the diagonal would be forming a 45-degree angle. 45 degrees angle on both sides, ha? Now, this 45 degrees angle can be used in order to find the x and y component nung angled force natin. So, para magawa yon, so sa x muna tayo. So, in order to get the x component nung force between Q1 and Q3, we simply take 0.036 newtons, 0.036 newtons, and multiply it by the cosine of 45 degrees. Now, we use cosine because we are getting the x. Now, that would be 0.025 newtons. Now, let's move on with the y component. Again, we just take the 0.036 newtons, and this time, we will multiply it by the sine of 45 degrees. And again, parehas lang sila ng value, so that would be 0.025 newtons pa rin. So, now, paano natin malalaman yung sign ng x and y dito sa Q1 and Q3? Like, yung x ba dyan ay negative, or both negative ba yung x and y, or yung positive lang ba dyan, yung y? So, malalaman natin yan based on the quadrant. Since yung angled force natin ay nasa quadrant 1, ito yon, this is our quadrant 1, positive parehas yung x and y niya. Positive. Now, kung halimbawa sa quadrant 2 yan makikita, yung x niya would be negative and yung y niya is positive. Kung sa quadrant 3 naman yan makikita, yung x niya ay negative and yung y niya ay negative. And then kung sa quadrant 4 naman yan nakita, yung x niya would be positive and the y would be negative. But since it was found in the quadrant 1, both x and y are positive. So both 0.025 newtons are positive. Okay, now let's move on with the x and y component of force between Q1 to Q4. So since again straight line na naman siya, isa sa kanyang x and y ay 0. So since horizontal siya, yung y niya naman ngayon yung magiging 0. And then the value of x would be positive 0.144 newtons. Bakit positive 0.144 newtons? But positive 0.144 newtons? As you can see, yung Q1 and Q4, meron silang attractive force. Ngayon si Q1, hinahatak siya ni Q4 to the right. And ang right ng Cartesian plane ay positive. So, the x would be positive. So, positive 0.144 newtons. Okay, so since meron na tayong mga values for our x's and y's, kunin naman natin yung summation ng x's and y's natin. So, for the x, add lang natin yung 0.025 newtons and 0.144 newtons. So, the answer would be 0.169 newtons. Ayan. So, sa summation of y naman tayo. So, add lang natin itong negative 0.072 newtons plus positive 0.025 newtons. And that would be negative 0.047 newtons. Now, since may summation na tayo of x and y, pwede na nating i-substitute yan sa Fnet formula natin. So, Fnet would be the summation of x squared, which is 0.169 squared, plus the summation of y squared, so that would be negative 0.047 squared. Yan. So, input nyo lang yan sa inyong mga calculator and the F net would be 0.18 newtons. Yan yung F net nung Q1. Pero, if we want to find the bearing at saka yung degree, yung kung north of east ba siya, tsaka kung anong degree, then pwede nating i-observe yung behavior ng summation of x and summation of y natin. So, tignan natin yung behavior nila. Balik tayo sa Cartesian plane. So, sa x, positive 0.169 Newton siya. So, to the right siya. Ayan. And yung y naman natin, negative 0.047 Newton siya. So, pababa siya sa y direction. Now, this would be the net force. Ayan, as you can see, yan yung net force. So, in order to find the degree and the direction of this net force, yung parang bearing niya, we just have to use the tangent. Now, kung nandito yung theta natin, this would be the opposite. Ito yung magiging opposite. Ito yung magiging adjacent. So, our formula for tangent would be tangent of theta is equal to the summation of y over the summation of x. Ngayon, since yung angle yung hinahanap natin, so that would be theta is equal to tan arctan is the summation of y over the summation of x. So, input lang natin sa calculator and that would be 15.54 degrees. And since itong portion yung kinuha natin, that would be south of east. South of east. Therefore, the final answer for the F net of Q1 is 0.18 newtons, 15.54 degrees south of east. Yan. So that's it. That's our final answer for the net force on the Q1.